Hello friends, welcome back to Academy of Hydraulic Engineers. Our today's topic is hydraulic fluids. Hydraulic fluid is the medium by which power is transmitted in a hydraulic system. It is relatively incompressible, making it ideal for force transmission with minimal losses. It is usually a light fluid which contains additives used for transmitting power. It influences the performance, maintenance costs, and service life of the hydraulic system. Hydraulic fluids can be classified as mineral oils, synthetic fluids, and water. Water presents many problems such as rust and corrosion, ineffective lubrication, temperature variation, and the hazard of contamination. Mineral oils and synthetic fluids meet all requirements for hydraulic performance. Roles of hydraulic fluids. Hydraulic fluids have to perform a variety of functions. First is power transmission. The most important function of hydraulic fluid is to transmit hydraulic power with minimum loss. Next is heat transfer. The hydraulic fluid carries away the heat generated in the system to the reservoir where heat is dissipated. Next, corrosion resistance. Hydraulic fluids to protect the metal parts against corrosion. Another function of hydraulic fluid is to lubricate. We know that there are a lot of moving parts in the hydraulic system, such as hydraulic pumps, hydraulic cylinders, valves, spools, etc. And all this needs to be lubricated. The hydraulic oil will lubricate the moving parts and reduce friction. Next, sealing. The hydraulic oil provides a final seal by filling the minute spaces between the O-rings and the metal parts. Sixth point is contamination removal. The hydraulic oil carries all dirt and wear particles from the system to the return filter or directly to the tank if there is no filter placed. Properties of hydraulic fluids. We have seen various functions of hydraulic fluids, and to perform these functions satisfactorily, the fluid must have certain basic properties. There are 6 basic properties in hydraulic fluids. First is viscosity, then viscosity index, third is demulsibility, then oxidation stability, lubricity, and sixth point is anti-rust and corrosion properties. Viscosity. It is the measure of fluid's internal resistance to shear or flow at a definite temperature and pressure. The viscosity is measured by viscometer in centistock units at 40 degrees Celsius. Now, let us do an experiment on viscosity, the pouring test. Take 2 bottles of same size, one filled with water and the other filled with honey. Pour the liquids one at a time into a jar and record the time required to pour out. You will observe that it takes longer to pour out honey than it does to pour out water. The reason is the flow resistance, the viscosity of honey is more than that of water. In other words, you can say that honey is more viscous than water. Now, let us see what happens if the fluid viscosity is high. High viscosity increases friction, resulting in high resistance flow, increased power consumption due to frictional loss, high temperature caused by friction, and increased pressure drop due to resistance. If the fluid viscosity is low, internal leakages increases. We know that one of the functions of hydraulic fluid is sealing, filling the minute spaces between the oil seals and moving parts. If the fluid viscosity is very low, this function will be comparatively less effective, which makes increased internal leakages. Second point is excessive wear and even seizure may occur under heavy load due to breakdown of oil film between moving parts. If the oil viscosity is low, then the oil film formed between the moving parts and the oil seals will be very thin, and that is the reason why this will break down under heavy load. Next, pump efficiency may decrease. If the internal leakage is more, that means obviously it will increase the volumetric loss, and because of that, pump efficiency may decrease. And fourth point is increased temperatures. Viscosity index. Viscosity varies with the change in temperature. For example, viscosity of VG68 oil is at 40 degrees Celsius is 68 centistock, and at 100 degrees Celsius it is 10.2 CST. See the variation. When the temperature increases from 40 degree to 100 degrees Celsius, the viscosity decreases from 68 centistock to 10.2 centistocks. This variation, the rate of change of viscosity with the temperature, is called viscosity index. Lower the viscosity index, greater the variation in viscosity with temperature changes, and vice versa. We have already discussed the problems with low viscosity and high viscosity. Therefore, too much variation in viscosity is undesirable because it adversely affects the performance of the hydraulic system. Therefore, we need a high viscosity index in hydraulic oil, and this viscosity index can be improved by adding additives. Next property is demulsibility. Demulsibility is the property of fluid which enables it to separate rapidly and completely from moisture and to resist emulsification. Emulsification means mixing of liquids. Next is oxidation stability. It is the ability to resist oxidation. When oxidation takes place, sludge is formed. Oil becomes darker in color, heavier in viscosity, and organic acids are formed. Oxidation stability can be improved by addition of synthetic oxidation inhibitors. Lubricity. Lubricity is the ability to minimize friction and wear. Anti-rust and corrosion qualities. Anti-rust and corrosion qualities can be improved by adding rust prevention additives. Pour, flash, and fire points. Pour point is the temperature below which the oil will not flow freely. Flash point is the temperature at which the oil begins to volatilize. That is, flammable vapor flash when brought into contact with a flame. And fire point is the ignition point of the oil. That is, oil vapors will continue to burn when ignited. Fire resistant hydraulic fluids. In areas of fire hazard, fire resistant hydraulic fluids are used. For example, tilting mechanism of a furnace, door opening or closing mechanism of ovens, etc. They can be classified as water-based fluids like oil-water emulsions, water glycols, etc. and synthetic fluids like silicones, phosphate esters, etc. Selection of oil. Selection of a suitable oil for the hydraulic system depends on 1. Viscosity of the oil should be compatible with the pump. For example, piston pump's viscosity requirement is between 10 to 160 CST. Second point is, oil should have the properties discussed earlier for better performance. And third point is, application requirements also used as a criteria in selection of oil. Most commonly used hydraulic oils in industry hydraulics are ISO VG68, VG46, and VG32. ISO stands for International Organization for Standardization. VG stands for viscosity grade. 68 means kinematic viscosity of the oil at 40 degrees Celsius is 68 CST. It is the midpoint. Actual viscosity varies from 64 to 72 CST. The midpoint is 68 CST. Maintenance of hydraulic fluids. In the beginning of the session, we have seen that hydraulic fluid influences the performance, maintenance costs, and service life of the hydraulic system. Therefore, it is very important to maintain the oil properly. Store oil in a clean container. Keep lids or covers tight on the oil containers. Keep oil drum horizontally. I have seen so many people keep the oil drum vertically in their yard or store. But that is wrong. The right way is to keep oil drum horizontally, that is 9 o'clock to 3 o'clock position. Next point is store in a dry place. Do not allow it to be exposed to rain or snow. Do not mix different types of oil. Use recommended hydraulic fluid for the pump. Do not add clean oil to dirty oil. Check the oil in the power unit regularly. You can send it to some laboratories for testing the properties. Next, drain the oil in the system at regular intervals. Exercise 3. Question number 1. The function of hydraulic fluid is to A. Lubricate the moving parts. B. Protect the metal parts against corrosion. C. Transmit hydraulic power. And D. All of the above. Question number 2. Viscosity of ISO VG68 grade oil referred to A. Kinematic viscosity of the oil at 100 degrees Celsius is 68 CST. B. Kinematic viscosity midpoint of the oil at 40 degrees Celsius is 68 CST. C. Kinematic viscosity midpoint of the oil at 40 degrees Celsius is 68 centipoise. And D. None of the above. Question number 3. Viscosity index is a function of A. Viscosity and pressure. B. Viscosity and temperature. C. Viscosity and flow. And D. None of the above. Question number 4. Variation of viscosity with change in temperature. A. Is more in oil of high viscosity index. B. Less in oil of high viscosity index. C. Constant. And D. None of the above. Question number 5. What is the flash point of ISO VG68 oil? A. 100 degrees Celsius. B. 212 degrees Celsius. C. 500 degrees Celsius. And D. None of the above. Question number 6. Best practice of hydraulic oil storage is by keeping the oil drum A. In the vertical position. B. In the horizontal position. C. Either A or B. And D. None of the above. Thank you. Thank you for the kind attention. If you like this video, please subscribe to support and get more videos on not only next sections of this course, but other topics as well.